Hi girls, Mr. Gilmore here, just coming at you with another one of these videos. Today we'll be working on presenting data, going a little bit further into that. You won't necessarily need to know the stuff that we did last class to be able to understand this one. Again, all you need to be able to do is know how to read a table of data, as you will be asked to be able to read, create, and use a bar chart. So our goal here is that you, by the end of this, understand how bar charts work more than anything else. So let's just dive straight in. What is a bar chart? It's a way of representing data. It's a way of presenting data, and it generally takes the form of something quite like this. So the idea here is that each bar that you can see here is labeled, bus, car, train, walk, bicycle, etc. And then you can see how many students do a certain thing, how many instances of it there are based on how high the bar is. Okay, so this bar chart shows how 60 first-year students generally travel to school. You can see, okay, 14 travel by bus, so 14. 12 travel by car, so you can see, okay, 12 travel by car. 8 travel by train. 16 walk, and 12 bicycle. So in reality, like, you're looking at this and you're going, okay, well, you can kind of immediately see, okay, more people take bus than train, more people take bus than bicycle. You can kind of immediately create a kind of tiering system in your own head as to how many people do each thing. And just as an idea, so one of the few things that I am going to say is all bar charts need to be equally wide. Just make sure that all of your bars are of equal width if you're doing any of these. And also, you'll notice that this y-axis, it's not going up in ones, it's going up in twos here. And I'm going to try to do more than one or two examples where it isn't just going up 1, 2, 3, 4, 5, 6. Instead, you can see, okay, it's going up in twos. So if we said, okay, well, actually there's a sixth category, the students who go by pogo sticks. Okay, so they pogo stick their way to school each day, and 3 students do that from first year. Well, then what we would do is we'd bring it up to like halfway between 4 and 2 here. Okay, so we'd bring it kind of halfway between the two, and you could go, oh, okay, 3 students go by pogo stick, just to give you an idea that, like, okay, some of these students, they kind of that this bar chart can still work even if it is a number that's between the values. So you just kind of have to approximate where it would be between them. Okay, so let's look at a few questions, and hopefully this will kind of click things into place. So the bar chart shows how many colors of cars in a car park. So they've gone through a car park, they've counted out each car. So how many red cars are in the car park? Well, you can see that the red bar goes up to 5. So you can go, okay, 5. So question 1's answer is 5. What was the most popular color in the car park? Well, you don't even need to go through each color in that case. You can just go, okay, most popular, that'll be the highest bar. So you can see, okay, white. White is 6, so white is most popular color. 3, find the total number of cars in the car park. Okay, how would we go about doing that? Well, we'd go about doing that by just calculating out all the bars and then adding them together. So we can see, okay, 6 people take black cars, 8 take white, 4 people had blue cars in the car park. There were 5 green cars in the car park and 2 purple ones. So 6 plus 5 plus 8 plus 4 plus 5 plus 2. I'd say take out your calculator, just quickly jot that into your calculator. 19, 23, 28, 30. 30 cars in total. Okay, so 30 cars. Fourth part, what fraction of the cars were red? Well, you can go, okay, 5 cars were red out of 30 cars, so 5 over 30, that'll end up equaling 1/6. And what I generally say here, girls, is before you start into a question where you know you're going to require information from an earlier question, check that earlier question, check if it's correct. Because if you've made a mistake here, you're not going to get here correct are you? And then finally, what percentage of the cars were black? So again, black was 6. 6 out of 30 equals 1/5. Well, that's 20%. Okay. So that's an example where it is just clean, going up in ones for each y value going up. Let's look at something a little bit tougher. Let's look at this question here. So now what we have is we have them grouped by years and then split into girls and boys, okay? So the number of girls and boys in what I'm going to presume is a mixed school. So how many girls, how many boys are in each year? So for this, I know I'm going to have to call back to this quite a lot. So what I'm going to do before I do anything else is I'm actually just going to write down the value for each of these just for myself, just to kind of make things a little bit easier for myself. So I'm going, okay, 24 girls, 24 boys, 20 girls, 28 boys, 12 girls, 24 boys. So there's 12 girls and 20 boys in first year, 24 girls and 24 boys in second year, 20 girls and 28 boys in third year, and 12 girls and 24 boys in fourth year. Okay. So first find the number of students in each of the 4 years. So we're just going to add these together. So I'm just going to jot down first, second, third, fourth. So 12 and 20. It's going to give me 32. 24 and 24, that's going to give me 48. 20 and 28, again 48. And then 12 and 24, that's going to be 36. Okay, so there's our first question. In what year is the number of boys the same as the number of girls? So in what year are these two bars the same? Well, you can immediately see that second year. Question 3. In which year is the number of boys twice the number of girls? So where is the bar twice as high for the boys than for the girls? Well, you can see that's fourth year. In which years are there 8 more boys than girls? So we want one that's 8 more higher, and we know each block is going to be worth 2 in this. Okay, so we can see that it goes from 0 to 4, so we know like that part's 2. Ooh. That part is 2, so each block is worth 2. So we can see that this one here has 8 in difference. So we're going to go, okay, third year. Which year has the least number of students? Well, we've already done that with question 1. Again, we're calling back to our earlier questions here. So just again, check your answers when you get to a question where you're kind of repeating a question. And then what fraction of first year students are girls? So again, we're calling back to our first question. 32 here, 12 over 32. That's going to be 2 in 5. Okay. Let's do one more question, and then I'm just going to talk about like the importance of bar charts in our lives. I'd say that we use bar charts way more than most of the other stuff I've taught you girls thus far. Like bar charts are just everywhere. People like ways to visualize data, to be able to just look at data and know things. That's so valuable. And I'll talk about an example of that. You probably have the exact example that I'm thinking of right now in your head right now. It's something that's always in the news. So the bar chart on the right shows the amount of money raised for new computers by 5 year groups in a school. Okay, so 1, 2, 3, 4, 5 year groups. Does year 1 have fewer pupils than year 3? So does it? Yes, because year 1 has a lower bar. Actually, wait, no. Ooh, this was a tricky one. The bar chart on the right shows the amount of money raised for new computers by the 5 year groups in a school. So this is the amount of money they've raised. So we can go, okay, the first years have raised €500. Second years have raised €700. Third years have raised €900. fourth years have raised €400, fifth years have raised €600. Does year 1 have fewer pupils than year 3? Now, we can see that year 3 has raised more money, but that doesn't necessarily mean that we can say that there are fewer students in year 1. Year 3 might just have, one person who was really, really good at raising money. Year 3 might have just been better organized. You could have 4 people in year 3 and 100 people in year 1 and still have that difference. Because this is only a bar chart of the amount raised. It's nothing to do with how many pupils there are in each year. You might be wondering, why then is this a question? It's very important that you guys are able to look at a graph and be able to reason out, okay, what is this graph saying? Not, okay, what is the actual information, but what is the graph showing me? This is just showing you how much money was raised, not how many students there are in a group. And in fact, using bar charts is so misused, and data is so misused, especially within the media right now, that it's so important that we are able to look at these graphs and be able to go, okay, this is the data that it's conveying. It's not telling me anything else. And an example of this, I'm going to scroll down a little bit and I'm going to show you a bar chart that I look at nearly every day. This is an old one. This is daily new cases in Ireland. You can probably figure out daily new cases of what. And the reason why I'm showing this to you is because there's an unusual little trait about this, right? There's something happening very, very frequently. You can see there's a little dip here, and then there's a little dip here, and then a little further on, there's another dip here, and then you can see again, there's another dip around here, right? So you're seeing these frequent dips. And I remember looking at these graphs and going, wait a second, there's a dip every 6 or 7 weeks on total. Like, okay, there's not a dip here. And the reason why, you'll notice that there's this giant jump here. You might have been following the news. I hope you are all following the news. That's the point in which we started getting help from German labs. So there was a backlog on testing the coronavirus patients. There was a backlog, and once the Germans started helping us out, obviously the cases bumped up. So all of a sudden, we were doing way more tests. So you do more tests, you have more cases. A lot of people might look at this graph and go, oh, clearly it got really bad at April 10th. No, this was them dealing with a backlog. All of these bars here should have been a little bit higher. But, okay, let's harken back to, okay, so there's one around 29th of March. Then there's another one around the 4th of April. There's a little one here, but that I'm going to ignore just for now, okay? There's another one around the 4th of April. Okay, you've got this big spike here, so we can't read anything from that. There's another one around the 19th of April. So 15 days after the 4th. And then there's another one around the 25th of April. You know what all those days were? Weekends. There were less cases being acknowledged each weekend on average, because I'm going to assume there's some lab or something somewhere in Ireland that just doesn't work on a weekend. So obviously, because less people are working on testing the cases, you're going to have less cases. So what you have to look at with most of these graphs is just the trend. You can see, okay, this is a bit of an outlier and this should be spread out over this, but we can see that there's kind of a continual growth. And now we're starting to see a little bit of an inching downwards, or we're starting to see that curve starting to flatten. But we can't guarantee that it is actually fully flattening, because the data is all over the place. Like, the data is jumping up and down and up and down. So just always be a little bit careful about any statistics you find about cases during all of this. Follow medical expertise, and just, wait until we know until we have enough cases, like we have enough data points that we can say, okay, this hasn't actually grown, instead of, okay, this is going down or this is going up. It's too soon to tell. Anyway, girls, thank you very much. Have a lovely, lovely day, and I look forward to correcting all your work. Bye-bye.